Everybody, can you hear me? Can you see my screen? Today we continue to learn chapter 13. We already finished the first three sections. Today we continue to learn section 4, applications and extensions of quadratic equation and formulas. First, let's recall what is a quadratic formula for general form of a quadratic equation. Let's say ax squared plus bx plus c equals 0. This one called general standard form of quadratic equation. If you use quadratic formula to solve this equation, the formula is x equals negative b plus minus then square root of b squared minus 4ac divided by 2a. Okay? So here the b squared minus 4ac called discriminant. Okay, usually we use delta to represent the discriminant b squared minus 4ac. You know, when delta is greater than 0, then we have two real solutions, two reals. Okay, when delta equals 0, we have one real solutions. Actually, that's two, but they're same. Then with delta less than 0, we have two complex solution. Then these two complex solutions, they're conjugate. That means if one is like a plus I times b, then another one will be a minus I times b. Okay, so this is a main point what we learn about the quadratic equation and the solution of quadratic equation. Now we need to use these knowledges in this section to help us solve the other problems. Now let's see first example, 13.13. Say 1 root of the quadratic x squared plus bx plus c equals 0. It's 1 minus 3i. If b and c are real numbers, then what are b and c? Okay, everybody think this problem. Actually, we have two ways to solve this problem. Say we have this equation, then we can use the formula. We can get x should equals negative b plus minus b squared minus 4 times a, because a is 1 here, so that's 4 times c, then square root over 2a. A is 1, so that means divided by 2. So this one, let's simplify. Let's write this one's two separate terms. That will be negative b over 2 plus minus b squared minus 4c square root divided by 2. Right? So this is a solution for this equation. Now, see, they already give us the one solution. It's 1 minus 3i So that means this one should equals 1. So that's negative b over 2. This one should equals 1. So from this, we can get b equals negative 2, right? So because you compare with this, this should equals 1 minus 3 times I, right? Say if you choose negative, you get a negative 1 minus 3 times I. So by this way, we got a b equals negative 2. Now let's plug negative b equals negative 2 to the discriminant expression. Now try to find the c. So we can get say negative 2 parentheses square minus 4 times c. This one square root over 2. Say this negative, this one should give you 3. But think here, you need this one because the solution is a complex number, right? So that means this one is negative. Otherwise, how you get this one is complex number. So that means we need to switch this order, because this one definitely will less than 0, right? So yeah, you can write this one equals I, 3i, that's fine. But if you just want to write this one is 3, that means you need to switch the order. Okay, make this one as 4c minus 4, right? Because negative 2 squared, that's 4. Then we can solve this equation. Say take the 4 out, you got this one's c minus 1 square root equals 3, right? Take the 2 out, 2 and this 2 cancel out. Then both sides square, you got a c minus 1 equals 9. So then c equals 10, right? So then say we got the solution for this one, b equals negative 2, c equals 10. This is one way, okay? This is one that's straightforward. But actually say the other way, because this equation has a solution, the complex number, right? So if the quadratic equation has a complex number as a solution, they should have 2 complex numbers as the solutions. And also these 2 complex numbers should be conjugate. So that means 1 minus 3i is a solution. That means 1 plus 3i will be another solution. Okay? This is a trick. You need to know this, okay? If you know 1 minus 3i is a solution, then that means 1 plus 3i is another solution. Then you can do x minus 1 minus 3i. This one is a solution, right? Then times x minus 1 plus 3i, that's another solution. Then you can expand this to compare with this. Now let's do this. So you can get x squared, right, minus, say, you can think this one like one number, right? You can this one's like m, this one as n. Then you can use the formula x minus m times x minus n. So this one, if you expand it, you get x squared minus m plus n times x, then plus m times n, right? If you expand this one, you got this. Now let's use this formula to here, then you got the minus, then m plus n. So this is negative 3i plus 3i, so you get the 2, right? Times 2, then times x, then plus this one times this one, that's 1, this 1 minus 3i times 1 plus 3i, right? Then let's continue simplify. We got a x squared minus 2x. Say 1 minus 3i times 1 plus 3i, this one just equals 1 squared plus 9. So that's plus 10. So then you compare with the left side, x squared plus bx plus c. So then we can get a b equals negative 2 and a c equals 10, right? Okay, this is the second way. Actually, we also have another shortcut to solve this problem. Okay, now let's think. You already know these two solutions, right? Based on the relationship. Suppose this one solution is this one is x1, this one is x2. So sum of this solution will equals this one plus this one, you got a 2. Then products of these two solutions will equals, say, 1 minus 3i times 1 plus 3i. If you expand this one, you got a 10. So now, say, in the previous section, we already learned the sum of two solutions actually equals negative b over a. This is for the general form, okay? The products of two solutions, that equals c over a, right? So then for this case, a, that's 1, right? So that means this one should equals negative b. So from this, we can get b equals negative 2, right? For this case, you know, a equals 1, so that means this one equals c, so that means c equals 10. So actually, see, for this problem, we use the 3 approaches solve this problem. We get the same answer, right? So the shortcut, that's use this kind of way. This is a shortcut. It's very easy, right? Now let's go to second problem, 13.14. So in this problem, we found all real numbers x such that this one equals 3. A, by what expression can we multiply both sides of the equation in order to get rid of the fractions? Multiply the equation by this expression. B, solve the equation that results from part A. Say, to multiply an expression to get rid of fraction for this equation, that's just need to multiply the common denominator of these two fractions. Say this one is 1 denominator of this fraction. This one is denominator of this fraction. So the common denominator of this fraction just multiply of product of these two expression, right? So that means we need times x minus 1 times x minus 2 to the both sides of this equation. By this way, we can get rid of the fractions. So use this one times both sides of this equation. That means you need to use this expression times each term in this expression. Now let's say we use this one times this. The x minus 1 cancels out. So you got a x times x minus 2. This one is the first term. Then the second term, x minus 2, cancels out. You only have x minus 1 left times 1. So then this one plus x minus 1. This one is the second term. This will finish the left side. Now right side, 3 times this one. So that's right, 3 times x minus 1 times x minus 2. Okay. Now let's expand it. Because this one is x squared minus 2x, then plus x minus 1. This one equals 3, then times x squared minus 3x plus 2. Okay, now let's continue. The left side will be x squared minus x minus 1. Right side, let's distribute this 3 here. There's 3x squared minus 9x plus 6. Right? So then, now let's merge the next terms, both sides minus x squared. Get 2x squared, then minus 8x. So both sides plus x. Get a negative 8x. Then both sides plus 1. You get a 7. This one equals 0. Right? So this is the equation we get. This is already the standard form. Now, to solve this equation, definitely first you need to try if you can factor it. Looks like we cannot factor. So then you can use quadratic formula. Say this one is 8, negative b, right? Plus minus square root of 8 squared minus 4 times a, that's 2, then times 7, then over 2 times a, that's 2 times 2. Okay, so now let's just simplify. Let me write that one here. X will equals 8 plus minus 8 squared, that's 64, minus 4 times 2 times 7, that's 56. Then this one square root divided by 2 times 2, that's 4. So now let's continue simplify. That's 8 plus minus 64 minus 56. You get a 8. Then square root over 4. So then we get this one is 8 plus minus 2 times root 2. So then we can this one divided by 4. So continue simplify. This one will give you 2 plus minus root 2 over 2, right? So we got this one is the solution, right? Now you need to go back check if this one is our real solutions. That means if this solution makes the denominator is 0. Looks like none of them can make the denominator 0. So that means these two solutions are solution of this equation, right? So then we got the solution for this equation. That's 2 plus minus root 2 over 2. So we got this. Now let's go to number 3. That's 13.15. See, in this problem, A, in this part, we found 3 different proofs that the roots of the quadratic x squared plus bx plus a times c equals 0 are 8 times the roots of the quadratic ax squared plus bx plus c equals 0, where a, b, c are constant and a is not equal to 0. Okay, see, they try to find the solution of this. It's 8 times of solution of this. Say, think this one actually is very straightforward. You can just use a quadratic formula, get this solution of this equation. Then you can use a quadratic formula, get solution of this one. Then you times a to the solution of this equation, this solution, then compare with this one. If check, they're same. Okay, now let's see how they teach us to do this. Say method one. Use the quadratic formula to find the roots of each quadratic, then use your result to complete the proof. Okay, so now let's do this first. To do this, this equation, the solution you can write that's immediately, that's equals negative b plus minus b squared minus 4 times 1 times ac, then square root, then over 2a. A is 1, so it's just over 2. This expression is the solution of this equation, right? Now, the solution for this equation, that's, let me write here, that's, suppose we use capital X to represent this. That will be negative b plus minus b squared minus 4ac, then square root divided by 2 times a, right? So then you compare this one with this, right? Say, if you times a to this one, then you get this. Say, we use a times this capital X, then get this one equals negative b plus minus b squared minus 4ac, then square root divided by 2a, then times a. So this a cancels out with this. So you got this one equals negative b plus minus b squared minus 4ac, then square root divided by 2. So this one actually equals this x, equals this, right? So then we prove this, right? We use this method 1, proved. The solution of this one, it's 8 times the solution of this one. Roots, that's the same meaning with the solution. So we proved this one use method 1. Now let's see method 2. Let R and S be the roots of this equation. Write an equation involve R, A, B, and C. Use this equation to show that x squared plus bx plus ac equals 0 when x equals a times r. How does this show that the roots of this one are 8 times the roots of this one? Okay, so the idea is this. First, you suppose R and S are solution of this equation. Then you can write an equation involve R, A, B, and C. Then use this equation, you can show that if R times A, that will be the solution of this equation. So that means the roots of this equation, it's 8 times of roots of this equation. Yeah, that's right. So now let's see. Suppose R and S is a solution of this equation, then we can get A times R squared plus B times r plus c. This one should equal 0, right? If r is a equation, it's a solution of this equation, right? Now let's see a times r if satisfy this one. So when x equals a times r, let's prog to here. That will be a times r parentheses square, then plus b times a times r, then plus ac. Then expand this one, got a square r square plus a times b times r, then plus a times c. So then you can find there have a common factor a. Then you take this a out. You got this one, it's a times r squared plus b times r plus c. This one equals 0, right? So then say, because we already know r is a solution of this equation, so that means a times r squared plus br plus c equals 0. So this one equals 0. So by this way, we proved x equals a times r, indeed the solution of this equation, right? So that means the solution of this equation is a times of solution of this equation, right? Yeah, that's approach 2. Now let's see third one. See again, let r and s be the roots of this equation. Find r plus s and r times s in terms of a, b, and c. Then find a times r plus a times s and a times r and a times s in terms of a, b, c. Then what quadratic has x squared as its quadratic term and roots x equals a times r and x equals a times s. Okay. So this one idea is this. You have this equation, right? Suppose you have two solutions, r and s. Then you can get r plus s and r times s. Use a, b, c to represent. Then you calculate this ar plus as and ar times as. Then based on this, you can write a quadratic equation. That quadratic equation should is this. Should be this one equals 0. Okay. By this way, you proved the solution of this one times a will give you solution of this one. Okay. Now let's do this. So r plus s will equals negative b over a, right? You know, for this standard quadratic equation, the sum of this solution should equals negative b over a. Then products of this solution should equals c over a, right? Now let's calculate ar plus as. So that's just times a to this one, got a negative b. Then ar times as. That's equals a times c, right? Because this one times a squared equals a times c. Then say based on the sum of solution roots equals negative b, the product of roots equals a times c. We can write that's quadratic will be x squared plus b times x, then plus ac. This one equals 0, right? See, this one, you can write this one over 1, this one over 1. Then you can write the equation will be x squared Then here the linear term that will be plus, because this one's negative b. So here that will be plus bx, then plus ac. So then see this equation is just what is the quadratic equation we're looking for. So then use these three ways we can prove the roots of this one is 8 times of this one. Now say B, use your result. You have now proved the 3 times to find the solution of the quadratic equation this one. Okay, say now they give you this quadratic equation. Can you find the solution of this equation? To do that, then you can just use a formula. Now let's see, we can use we can get x equals negative 17 plus minus 17 square minus, so there will be plus because 18, this one's negative 18. So 4 times 15 times 18, then this one square root, then over 2 times a, so 2 times 15. So if you simplify, see what you get. Everybody do this. See what is x you can get. Okay, now let's see. This one, so you can get this, simplify this one, you can get x equals negative 20, negative 9 over 5. Another one, it's 2 over 3. So to, this one, we just use this formula, right? But actually, there's a shortcut. You can compare this equation with x squared plus 17x, then minus 18 times 15 equals 0. Because this one, the roots of this one equals a equals 15 times roots of this one. So you can find the roots of this equation. After that, you just divide by 15, right? So now let's see this one. Actually, you can factor in. You can write this one equals x plus 27 then times x minus 10. Because 18 times 15 equals 270, then you can factor in this one as x plus 27 times x minus 10. By this way, you can get x equals negative 27 and 10. So after you get this, then you know the solution roots of this equation actually equals negative 27 divided by 15. Another one is 10 divided by 15. Then you simplify this, you get a negative 9 over 5. You simplify this, you got 2 over 3, right? So then say, if you know this facts, the solution of this equation actually is 8 times of solution of this one. So we try to solve this one. This one's, if you solve this one, you cannot factor it at all. You have to use a quadratic formula. But if you know this fact, you can solve this equation first. You solve x squared plus 17x minus 270. Then this equation you can factor in. as this, then you get the solution of this equation equals negative 27 and 10. After you get this one, each solution divided by 15, then you get the root of this equation. Okay, so this is a very smart way. Now let's go to 16. So this problem said, in this problem we found all the values of m for which the roots of 2x squared minus mx minus 8 equals 0 differ by m minus 1. Okay, so that means they give you this equation, quadratic equation, then this quadratic equation have two solutions. The difference of these two solutions equals m minus 1. Then A, find the expression in terms of A, B, and C for the difference between the roots of the quadratic equation ax squared plus bx plus c equals 0. Okay, then B, solve the given equation. Okay, so yeah, this is a very straightforward approach. Say, for this quadratic equation, we can use quadratic formula to get the expression of their solution that should equals negative m. So you got a positive m plus minus, then negative m squared, that's m squared, minus, because here's minus 8, so it will be plus 4 times 2 times 8, then square root, then over 4 over 2 times a, that's 2, right? So then now let's simplify this. This will give us m plus minus m squared plus 64, then square root over 4, right? Then they tell you the difference of these two. Here you have two solutions. They tell you difference of these two solutions equals m minus 1. So then you can use m, the one solution, that's m plus m squared plus 64 square root, this one divided by 4. Another solution that's m minus m squared plus 64 square root divided by 4. So then the difference of these two solutions equals m minus 1. So then you say you use this one minus this, then you can get that m squared plus 64 square root. See, this one, m, the first term cancels out. You only have the quadratic term left. That will be x squared plus 64 square root. See, this minus changes to plus. This one divided by 2. Because you have 2 over 4 divided by 2, this one equals m minus 1. Then both sides times 2, you get the m squared plus 64, then square root, this one equals 2 times m minus 1. Right? To solve this equation, the easiest way, just both sides square. You get m squared plus 64 equals 4 times then m squared minus 2m plus 1, right? So then now let's write this one here. Let's try to simplify. So we can do m squared plus 64 equals 4m squared minus 8m then plus 4. So then both sides minus m squared, you got 3m squared. Then minus 8m. Then both sides minus 64, that's minus 60. Then this one equals 0, right? Now we can just use quadratic formula. You can try, see if you can factor in. If you don't want to try it, you can just use a quadratic formula. You got m equals 8 plus minus 8 squared, that's 64 minus, so that would be, because here is a minus, so it'll be plus 4 times 3 times 60, then square root, then divided by 2. So then we can get say this one is 12 times 60, that's 720. 720 plus 64, that would be 784. This one square root divided by 2. Now let's simplify this, see what we get. You got this one, let's see, 1, we get 784. Actually, here you can factor in, but anyway, now let's see, 784. First, try to use 4 divided, right? Because 84 divided by 4. So you got a 138, that will be 9, then 6, right? So 196, so that's equals 16, right? Is this one 16? No, 13. 13 times 13, that's, oh wait. Let's see, 16 times 16, 36, no. So 196, we can still use 4 divided by this one, get that 49. Okay, so that means 14. So then that means this one we can write 8 plus minus 2 times 14, that's this equals 28 over 2. So then you get if we choose this one as plus, that will be 8 plus 28, 36. 36 divided by 2, that will be 18. If we choose this one's negative, that will be negative 20 divided by 2, that will be negative 10. So we got 18 at negative 10. So this one, it's let's say, okay, this one say m divided 2 times 3. Here should times 3 because this one is 3. So here times 3 times 3. So this one should divide by 3. Divided by 3. Yeah. So then you get the solution for this one 6 and negative 10 over 3. Okay. So we got this this solution, these two solutions. One is 6, another is negative 10 over 3. So here we use quadratic formula. Looks like this one you can factor in 1 over 3. Then this one should be, this one's 18. This one it's this one should be, let's see. No, the equation is this, right? So 1, 3, now let's see, 18 and this one's 10, so looks like, suppose this one is 1, 3. So 60, now let's see, if we write this one is 10, this one is 6, that's not good. So if this one's 6, this one's 10, if this one's 6, if this one's 10, that works, right? So then we make this one as negative, right? So say 3 times negative 6, that's negative 18. Negative 18 plus 10, so you got negative 8. Yes, so that means this factor works. So m minus 6 times 3m minus 10 plus 10 equals 0. By this way, we got m equals 6, and another one is negative 10 over 3. Yeah, this one's correct answer. Now, you need to go back, check if these two are real satisfy the original equation. You know, we get m equals we get m equals 6. Another is m equals negative 10 over 3. So in that equation, you know, we use the m squared plus 64 square root this one over 2 equals m minus 1, right? So at least your solution need to guarantee this quadratic root 2, this one should greater or equal 0, right? If m squared plus 64 is less than 0, definitely that's not be the solution. So now let's check. Definitely this one, say, when the left side definitely is positive. Now let's say the left side is positive. Let's check the right side. Say m equals 6, this one will equals 5. That's fine. But when m equals negative 10 over 3, this one will be a negative number, negative 13 over 3. Say this, the right side is a negative number, but the left side is positive number. So that means this one is not a solution. This one is not a solution. The reason why we get this one, because we both sides square. Then, you know, original probably it's say 1, the left side is 1, the right side is negative 1. Then when you square it, you get a 1 equals 1. So that's they're satisfied. But actually the negative 1 is not the solution. So then after you squared both sides, later you need to check if this solution you get are real the solution for this quadratic equation. So then the correct answer for this one is only 6. Negative 10 over 3 is not the solution. It's not what we're looking for. So now, see, we already finished this section. We already finished this chapter. Your homework, you need to finish this exercise problems in this section. Then say now let's summary what we learned in this chapter. Okay, in this chapter, I think the most important it's formula for quadratic equation is this. The most important is quadratic formula for quadratic general form of quadratic equation. Then you also need to know the discriminant. when the discriminant greater or equal 0, you have the roots of quadratic equation are reals. When this one less than 0, the roots of quadratic that's not real. That means complex numbers. Then also you need to know this. The sum of the solutions of quadratic equation equals negative b over a. The products of quadratic equation that's equals c over a. Okay, this one is very useful. Use this one, you can solve a lot of problems. Okay, then later you need to finish the review problems. For challenge problems, you can do it if you like it. We don't require you to do it. Now we still have about 10 minutes. Now let's go to chapter 14. Graphing quadratics. This one actually is very interesting and also very important. Now let's see first example. 14.1. Graph the equation y equals x squared by first plotting several points that satisfy the equation to figure out what is a graph looks like. Is the graph symmetric? In other words, is one half of the graph a mirror image of the other half? Why or why not? Okay, to do this, now let's calculate sum of the numbers. Let's get this table. Suppose this column that's x, this column is y. Now first let's prog x equals 0. So we're gonna y will equal 0. Now let's prog x equals negative 1. Then get a y equals 1. Now let's prog x equals positive 1. Then get a y also equals 1. Now let's prog x equals negative 2. Then get a y equals 4. Now let's prog x equals positive 2. Get a y equals positive 4. Then we can draw this graph of this function like this. See, you look at this point. First one, when x equals 0, y equals 0. Then when x equals negative 1, suppose here's x equals negative 1, here's x equals positive 1, here x equals 2, here x equals negative 2. So then when x equals negative 1, suppose y, this 1, this one is 2, 3, 4. So then you got this point, right? When x equals negative 1, y equals 1. Then you also get when x equals 1, y equals 1. You also got this point. Now when x equals negative 2, you get a y equals 4. So it's about here. Then when x equals positive 2, you also got a y equals 4. So it's about here. So now let's see. If you draw this right half, this will be like this. Right? Then if you draw the left side, that will be like this. Something like this, right? Then say there's symmetry, right? What I draw here definitely is not perfect. But then if you use a calculator, or now let's say if we use a software, if we draw this function y equals x squared, see, you get the perfect symmetry graph of this function, this quadratic function. This graph is called parabola. Parabola. This shape called parabola. Okay. Then why this one? They ask you why this one's symmetry. To explain this one, just you need to do this. When you plug negative x to this function, you get this one will equals x squared, right? So then now let's suppose this function as fx for a function y equals fx. If you have f negative x, then equals fx. This kind of function called even function. Even function. Even function is a symmetry about y-axis. All even function is symmetry about y-axis. Another kind of function called odd function. So that means if you plug negative x in it, you get a negative fx. So this kind of function like y equals x, right? When you plug negative x here, you get the negative x will equals negative y, right? So that means you get a negative fx, f negative x, we got a negative x. This one will equals negative fx, right? Another example, that will be y equals x cubed. This one, when you plug negative x in it, you get that negative x will equals negative x power 3. Then this one equals negative fx. So this kind of function called odd function. Odd function is symmetry about origin. Now let's graph this odd function. If we graph the x power 3, see, you get the graph of this function is like this. This function is symmetry about the origin, about this point, right? But for the even function, like y equals x squared, y equals x squared, this one is symmetry about y-axis. Okay, so this it's what I just want to let you know. So see, then they ask you, is this one half of the graph of the mirror of the other half? Why or why not? You know. Yes, the answer is yes. Why? Because this one is an even function. So then the symmetry about the y-axis. Now let's go to second problem. This one said they ask you graph y equals 5x squared, y equals x squared over 5, and y equals negative x squared over 5. Then they ask you what effect does the coefficient of x squared have on the graph of a quadratic. Let's see. Say this one is y equals x squared, right? Now let's say let's graph y equals 5 times x squared. The green color is y equals 5 squared. So then now let's graph y equals x squared, this one divided by 5. The pink color is y equals x squared divided by 5. Now let's graph another function. It's y equals negative x squared. See, then you can see clearly the effect of the coefficients. Say from x squared to 5x squared, the graph become leisure, right? Then that's the stretch on the y direction. Say, compare, this one with this. See, this one is x squared. Then this one is 5x squared, right? So then the graph become leisure, and also you can consider that's the stretch on the y direction. This one is x squared over 5. Then, but they all this positive. Then this graph is open up, right? They open up. If you change this one's negative number, then they will open down, right? So then this is the effect of coefficient. So time's up. We can stop here. Then your homework, that's finish all the review problems and exercise problems in section 13.4, and also try to finish the problem in the 14.1. So we can stop here. Do you have any questions? Okay, so then we can stop here. Everybody, bye.
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 Thank you. Bye.
Bye. Bye.